Bismillahirrahmanirrahim. In this video we will study discrete probability distributions. Different discrete and continuous probability distributions are included in your syllabus. The first is the binomial probability distribution. And what is the binomial probability distribution? Binomial probability distribution used for a particular types of variable. In video number 11, 12, 10, 11 and 12, you have solved different types of questions in probability, and you know that the basic formula of probability is number of favorable outcomes divided by possible outcomes. With the help of this formula you have solved different questions. In first question, video number 10, if you throw a coin, question number first is when we throw a coin 3 times, know that the possible outcomes are 8. In this experiment, first we draw all possible outcomes and outcomes of the event according to the condition. For example, number of 3 heads occur, number of 1 heads occur, and so on. And then we write the value of the favorable outcome of the event in numerator and possible outcome in denominator for the probability. So in this question number 1, video number 10, you can draw all possible outcome and favorable outcomes for the probability, because the basic formula of the probability is the number of favorable outcome divided by possible outcome. In second type of question number 2 and 3, the possible outcome and favorable outcomes are given, known. For example, suppose you have solved this question in a class of the 100 students, 54 studied mathematics, 69 statistics, and so on. Possible outcome are 100, outcome of the event mathematics 54, the student studied statistics 69, this is the favorable outcome. Using the same formula, classical approach of the in probability, you have used the formula of the number of favorable outcome divided by possible outcome for probability in question number 2, and same as in question number 3. In third type of question, you have used combinations for all possible outcomes and favorable outcomes. And when we apply this formula of the combination, because you know that the formula of the combination and permutation used for possible outcomes. So when we use the combination for without order arrangement, we use the combination for possible and favorable outcome. You have used this formula in question number 5. Select 3 books from 8 novel books, 3 books of poem, 1 dictionary, etc. Okay, this is the question number 5. You have solved this question in video number 12. In these 3 types of question, you have used the formula of the classical approach, number of favorable outcome divided by possible outcome. Probability of any event, any condition is equal to number of favorable outcome divided by number of possible outcome. So there are different methods for drawing all possible outcome and outcomes of the event. Sometimes the favorable and possible outcomes are given or known. Sometimes we find with the help of experiment. For example, if you throw a coin 1 times, 2 times, 3 times, 4 times, you can draw all possible outcome and favorable outcome with the help of this experiment. And sometimes we use the combination and permutation, and sometimes may be given or known. The target and objective is find the number of favorable outcome divided by possible outcome. So when we use property distribution, this is the important thing. And you know that if you distribute the frequencies, table is called frequency distribution table. If you distribute the probability in the form of table or according to the values of the random variable x, the table is called probability distribution table. You have done in mathematical expectation in last video, previous video. So if you distribute the probability according to the value of the outcomes of the random variable, suppose if you throw a coin 3 times, the possible outcomes of the number of heads may be 0 head, 1 head, 2 heads, 3 heads. You have done this question in last video. So probability distribution means distribute the probability. But when we use the binomial probability distribution, this is the important thing. The probability distribution, different probability distribution like binomial distribution, Poisson distribution, normal probability distribution, hypergeometric, geometric, there are different types of probability distribution used according to the characteristic of the variable or according to the outcome of the variable. Variable may be discrete or continuous. First we will study binomial probability distribution, then Poisson probability distribution. Both are discrete probability distribution used for discrete variable. But what is the difference between the binomial probability distribution and Poisson probability distribution? This is the most important thing. So sometimes you cannot draw all possible outcomes like the coin, or you cannot draw all the possible outcomes with the help of permutation or combination, or may be unknown. Then we use different probability distribution. Then we use different probability distributions. Formula of the different probability distribution. The first probability distribution is the binomial probability distribution. We select the different distribution, different probability distribution according to the characteristic of the outcomes of the variable. Variable, there are two different categories, discrete or continuous variable, and we have different discrete probability distribution, different continuous probability distribution. So what is the difference between the discrete probability distribution? This is the important thing. So we select, the most important thing is we select the probability distributions according to the outcomes of the variable or according to the characteristics of the outcome of the variable. So what are the characteristics of the binomial distribution? This is the most important thing. So this is the definition of the binomial probability distribution. This is the characteristic of the probability distribution. I will explain one by one. one widely used probability distribution of a discrete random variable. In probability distribution, we will use the word random variable instead of variable. I have already explained in last video. Is the binomial probability distribution. Bi means two, nomial means outcome, two outcomes, two results. The binomial distribution describes a discrete data, outcome will be discrete, resulting from an experiment known as Bernoulli process. Binomial theorem you have done in mathematics. Binomial theorem and binomial probability distribution both are same, and this is the name of the mathematician Bernoulli. You have used this name in binomial theorem in mathematics. We can describe this process. What is the process or binomial experiment as follows? These are the characteristics of the binomial probability distribution. Number first, the experiment consists of n repeated trials. N repeated trial means, suppose if you throw a coin one time, two times, three times, four times, is called repeated trials, and is also called statistical experiment. If you throw a coin one time, outcome will be two, two times will be four, three times eight, and so on. You have done in previous examples. And this trial has only two possible outcomes. Each trial has only two possible outcomes, maybe head or tail, yes or no, pass or fail, survive or die, 0 or 1, etc. So if you throw a coin one time or two times, three times, this experiment is also called the binomial experiment. You can use the binomial probability distribution for the probability of random variable x. If x is the number of head occur, if you throw a coin three times, you know that maybe 0 head, 1 head, 2 heads and 3 heads and so on. You can also use the binomial probability distribution for this example. You have solved this example many times. You can find the probability with the help of binomial probability distribution. But sometimes you cannot draw the possible outcomes, then we use binomial probability distribution. Suppose if a student appear in examination, maybe pass or fail, there are two possible outcomes, pass or fail. A patient admitted in a hospital, maybe survive or die, improve or unimprove. In this type of experiment, you cannot draw all possible outcome or outcome of the event or favorable outcome. Then we use binomial probability distribution. In this example, if you throw a coin one time or two times, three times, you can draw the possible outcomes. So this is the most important characteristic of the binomial probability distribution. If any variable has two possible outcomes like this, yes, no, true, false, success, failure, pass, fail, survive, die, improve, unimprove, 0 and 1, then we use the binomial probability distribution for probability. Number third, the probability of the outcome of any trial remains fixed over time. Probability will be same, 50-50% chance, 1 upon 2, 1 upon 2 if you throw a coin one time or two times, three times. This is a characteristic of the outcome of the variable. Chance of occurrence fixed over time. If you throw a coin 2 times or 10 times, 1000 times, chance will be same, equal. The repeated trials are independent. I have already explained this characteristic in independent events. If you throw a coin one time or two times or three times, outcome will be independent. If you throw a coin 10 times, out of 10 times, 9 times head appear. 10 times maybe head or tail, both are independent, not dependent. This process called Bernoulli process. The most important characteristic of binomial probability distribution is each trial has only two possible outcomes, head or tail, yes, no, true, false, success, failure, pass, fail, 0, 1, etc. So if any variable satisfy or follow these characteristics, then we use binomial probability distribution. And binomial probability function means formula, a formula which is used to calculate the probability of x successes in n Bernoulli trials, where p is the probability of success in a single trial, q is the probability of its failure, such that p plus q is called binomial probability mass function, is given by this. This is the formula of the binomial probability distribution. In general, we use f of x for probability distribution. We use probability of x is equal to x. For any given condition, we use this notation. For binomial, B for binomial, x and p, x is the variable and number of trials, and repeated trial 1 times, 2 times, 3 times, p is the probability of success. If you throw a coin, head will be the success, tail will be the failure. Summation x is equal to 0 to n combination x. This is the formula of the combination p power x, q power n minus x. Or this is the formula of the binomial probability distribution. This is equal to p plus q power n. You have used this formula in mathematics, a plus b to the power n. So here we are using p and q instead of a and b. So x is the success condition. We always find the property of variable condition in n Bernoulli trials. Out of n, how many x will occur? P is the property of success, because there are two possible outcomes, head success, tail failure, yes success, no failure, pass success, fail failure, survive success, die failure. And sum of the probability is always equal to 1. So P is the probability of success in a single trial, Q is the probability of its failure, such that sum of the probability will be equal to 1, is called binomial probability mass function, is given by this. We will use this formula for the probability of any condition when n and p are known, given. N, p are known, given. N is the number of trials, 1 times, 2 times, 3 times. P is the probability of success. Okay. So next heading, properties of binomial distribution. It is univariate, single variable univariate x, and discrete type of probability distribution. It has two parameters n and p. N and p is called parameter, and p plus q is equal to 1. Both are probability. So you can also write this p is equal to 1 minus q. If you write right hand side, in previous slide, p plus q equal to 1, so p will be equal to 1 minus q in term of failure. Both are same probability, but this is the probability of success, this is the probability of failure. So n, p are parameter. Parameter means population value, given value, standard value. With the help of n and p, we can find the probability of x. This is the formula of the binomial probability function. This is equal to p plus q power n. You have used this formula in mathematics. A plus b power n is the binomial theorem. If you expand this, you will obtain this. If you substitute different values of x is equal to 0, 1, 2, 3 up to n, you will obtain this. Or if you expand this, you have done in mathematics, you will obtain this. Sum of the probability equal to 1, 1 power n is equal to 1. The sum of the probabilities is always equal to 1. Mean is equal to np, mu is equal to np. Without any frequency distribution table, if you multiply the number of trials with probability of success, you will obtain the mean of the data. And variance sigma square will be equal to npq. Q will be equal to 1 minus p. And standard deviation sigma will be square root of this term npq. Mean will be greater than variance. If you calculate the mean and variance, mean will be the greater than variance. If P and Q are equal half, then distribution is symmetrical. If you plot the data with equal probabilities, P equal to Q equal to half, the distribution is called symmetrical. Graph will be symmetrical. P greater than half, then distribution is negatively skewed. P less than half, positively skewed. Okay. Now we will solve example question. This is the first question. The probability that a patient recovers from a disease is 0.4. Patient recovers, success, from a disease 0.4. This is the probability of success. If 15 patients, 15 total number of patients, n, are known to have contracted this disease, what is the probability that first part exactly 5 survive? First we will decide either the variable, outcome of the variable is binomial variable or not. And you know that patient recover is a success and outcome may be survive or die, improve or unimprove. Question is find the probability of exactly 5 survive. The patient may be survive or die. This indicate the outcome of the variable is 2, survive or die. So we will use the binomial probability distribution. This is the condition. P equal to 0.4, n is equal to 15, Q will be equal to 1 minus P, 1 minus 0.4 will be 0.6. First part exactly 5. Find the probability of exactly 5 means equal to 5. So we will substitute the values of the NP and Q in formula. In this condition you have only one value. We will eliminate or ignore the summation sign. Summation sign used for more than one values. So n is the 15, x is the 5, p 0.4, x power 5, 0.6 power n minus 5, n minus x, 15 minus 5. 15 combination 5, solve using the formula or calculator. We will obtain these 0.4 power 5, these 0.6 power 10 is equal to this. The probability is 0.186. So if 15 patient contact to the doctor, in this the most important thing is the doctor should be same, disease should be same. Then you can use the given value of the probability for the next condition for the probability. And how we obtain this value 0.4? This is the standard value, given value. Suppose if you collect the data, or any doctor collect the data, first day, in second day, in third day. In first day, suppose 10 patient contact to the doctor for his or her disease. Out of 6 patients, 4 survive. Probability of success will be 0.4. Next day, out of 20 patients, 6 survive. Probability will be equal to 0.6. And so on. If you collect the data up to 1 month, and the average probability is 0.4. And then you want to calculate the probability of exactly 5 patients survive if next day 15 patients are contracted this disease. What is the probability of exactly 5 survive, exactly 5 patients survive? So we will use this value because this is the parameter value, P is the parameter for the next. So this value obtained with the help of large data or standard value, previous data and so on. So you can find the probability of the different conditions. There are different types of the conditions. Maybe exactly 5, maybe between 3 and 5, less than, more than, at least, at most, fewer than, and no survive. This is the survive, not service. Okay, so possible conditions are different, 7 conditions exactly, between, less than, more than, at least, at most, fewer than, and no. Exactly means 5, equal to, we will use this. Between means you have 2 conditions, lower and upper value. X will be greater than equal to 3, less than equal to 5, and so on. We will study one by one. I will solve each part one by one. So the probability of exactly patients survive if 15 patients are known to have contracted to this disease is 0.186. Now second part, between 3 and 5 survive. Between 3 and 5 means x greater than equal to 3, less than equal to 5. There are different values of the x from 3 to 5. 15 is constant fixed, n is 15, p is constant 0.4, q is fixed for this question 0.6, but value of x is vary from 3 to 5. We will substitute the value of x one by one, first time 3, second time 4, then 5, and simplify this 15 combination 3, 0.4 power 3, this power 0.612, plus sign, same as simplify this term, this term, this term, and this condition is same as the previous part, exactly 5. The probability is 0.186. You can use in this question as it is 0.186. Simplify this, you will obtain the probability of 3 to 5 patients survive, 0.376. Next part, less than 3. And this is the discrete distribution. Patient is the discrete variable. Less than 3 means from 0 to 2. So we will substitute in same formula value of x from 0 to 2, first time 0, then 1, then 2, and simplify using the formula of the combination, and this term plus sign, this term plus sign, this term, you will obtain 0.0271. So probability of less than 3 patients survive, 0.0271. Okay. Next part, more than 12 survive. More than 12 means from 13 to 15. Greater than 12 means from 13 to 15, because the maximum number of patients is the 15. It will start from 13, the last will be equal to 15. Substitute here different values of x one by one, same as the previous part. First substitute 13 plus sign, then 14, then 15. Simplify, you will obtain the probability of more than 12 patients survive. Next part is at least 10 survive, minimum 10, maybe more than 10 to above. Minimum at least 10 survive, 10 to above, minimum 10, maybe more than 10. I have already explained this type of condition in first and second example, video number 10 and 11. At least 10, minimum 10, but not less than 10, maybe more than 10. So 10 to above, 10 to 15, substitute one by one. First substitute 10, then 11, 12, 13, 14 and 15. Value of 13, 14, 15 are given in this. You can use in this part. At most 5 survive, maximum 5. ज़्यादा से ज़्यादा 5. Not more than 5, but maybe less than 5. So less than 5 means minimum value will be equal to 0 patient. So from 0 to 5, substitute one by one here, 0, 1, 2, 3, 4, 5, and you have already calculated different values of x, and previous part you can use in this part. Less than 3, fewer than 3. Fewer than 3 and less than 3 same thing. Less than 3, 0 to 2. Fewer than 3 means up to 3 but not include 3. Same as the third part, right? Direct answer here, value of less than 3. x equal to 0, you have already calculated this value in this part, you can write only the value of the first part, x equal to 0, write direct answer here. But this procedure, this calculation is very lengthy and time consuming. For one value and two values, three values, you can calculate direct using the formula. But all the values from 0 to 20, when n is from 0 to 20 and x is from 0 to 20, with different values of p equal to 0.1, 0.2, 0.3 up to 0.9 are given in your book in the table of the binomial property distribution table. Now we will solve again same question using the binomial property distribution table. So this is the binomial property distribution table, the given in your book, Walpole book, from page number 471 to 476. But according to this question, previous question, we will select page number 474 because the different values of n is given like this. If n is 1, value of x will be 0 to 1. If n is 2, value of x will be 0 to 2. N is 14, value of x will be equal to 0 to 14. N is 15, value of x will be from 0 to 15. So in this question, in the value of n is 15, value of p is 0.4, so we will select the table according to the values of the parameters. Parameter means value of n and p. First we select the n. In this question n is 15. Then we select the value of p. This is the value of p. According to this question we will select this column. P is the 0.4. All the values are given here. This is the value of the 0. If n is 15, p is 0.4, probability is 0.0005. This is the area of the probability. So we will find the probability from this column. First we will select the table according to the value of n. There are different pages from 71 to 76. On page number 474, value of n is given 15. P 0.4 is given in this column. We will select this column for this question. And this is the probability of exactly x is equal to 0. This is the most important thing. And this is the value of the property x is equal to from 0 to 1, not only 1. This value is included in this value. This is the cumulative probability. You can observe from the last values, you know that the sum of the probability is always equal to 1. So maximum probability is 1 indicate this is the sum of the probabilities. And if the value of probability is 1, the next value will be always equal to 1. If the minimum value is 0, the previous value will be equal to 0 because you know that the minimum probability is 0. If suppose these values are not given, but this is understood the maximum probability is 1, value will be equal to 1 and minimum will be equal to 0. In your book these values are not given, 0, 0, 0 again and again, and 1, 1, 1 is not given again and again. So, and this value, when n15 p 0.4 x is equal to 2, this is the probability of from 0 to 2, not only 2. Suppose if you want to calculate the probability of exactly 5 patients survive, so we will subtract the previous value from this value because this is the probability of from 0 to 5 and this is the probability of 0 to 4, this column. we will subtract this value 0.2173 from this for the probability of exactly 5. Because this is the probability of 0 to 5, this is the probability of 0 to 4. If you subtract the value of from 0 to 4 from 0 to 5, you will obtain the probability of 5. Okay, now we will solve the question again using the binomial probability distribution table. Using binomial probability distribution table, page number 474, and is 15 p.4, exactly 5 patients survive. So how we represent the condition? Don't write the formula here, write only notation. B for binomial, X variable, 15 is fixed for all the parts, 0.4 is the fixed parameter value. So we will write like this: value of from 0 to 5 minus value of 0 to 4 for exact 5. So value of 0 to 5 means this value 0.4032. This is the value of 0 to 5 minus the value of 0 to 4. This is the value of 0 to 5 minus 0 to 4. 0.4032 minus 0.2173. 0.4032 minus 0.2173. Okay, so if you subtract from 0 to 5, 0 to 4, you will obtain 5. This is a logical thing. Subtract this value of 0 to 5 minus 0 to 4, you will obtain same answer, 0.1859. 0.1859. 59 approximately equal to 6. Second part, between 3 to 5. So if you subtract from 0 to 5 the value of 0 to 2, 0 to 5, subtract 0 to 2, you will obtain from 3, 4, 5. So 0 to 5, this is from 0 to 5, this value 0.4032, subtract 0 to 2, this value 0.0271. If you subtract from 0 to 5, value of 0 to 2, you will obtain 3, 4, 5. So same as here, probability of this 5 indicate probability of 0 to 5, not only 5, because this is the cumulative probabilities. 0 to 5 minus 0 to 2, 0.4032 minus 0.0271, 0.4032 minus 0.0271, this is the probability of 0 to 5 minus 0 to 2, you will obtain same answer, 0.3761. 0.3761. And next part, less than 3 means 0 to 2, so we will write direct the value of 2, because 0 to 2, 0.0271 direct, because this is the probability of 0 to 2. Probability of 0 to 2. So, write direct 0.0271 is the probability of 0 to 2. Same answer. Now next part, instead of long calculation, lengthy calculation, you can write greater than 12 like this, because you know that the maximum probability always equal to 1. And greater than 12 means from 12, 13, 14, 15. 13, 14, 15. If you subtract from 1 the value of 0 to 12, you will obtain 13, 14, 15. From 0 to 12, total probability is 1. This column 1. If you subtract from 1, 1 means probability of 15. Subtract from 0 to 12, subtract this value 0.997. So from 0 to 15, subtract 0 to 12, you will obtain probability 13, 14, 15. So from 1 subtract 0 to 12, you will obtain this probability. Next part, greater than equal to 10. For more than, we will subtract from 1. Here this is also from above 12, 13 to 12, more than. Same as here, for more than, we will subtract from 0 to 9 because the required condition is from 10 to above. If you subtract from total probability the value of 9 from 0 to 9, then you will obtain 10, 11, 12, 13, 14, 15. So value of 0 to 9, 0.9662. 0 to 9, 0.9662. From 1 subtract 0.9662. From total probability 15, subtract the value of 9. 0.9662, you will obtain 0.0338. Next condition, less than equal to 5. At most 5 means from 0 to 5, write direct. Instead of lengthy calculation using the table, you can write direct 0 to 5. Value of 0 to 5 means the value of 5 is the value of 0 to 5. 0.4032, write direct this value. 0.4032. Less than 3, fewer than 3, both are same, write direct value of 2. Value of 2 means 0 to 2. X is equal to 0, 0.0005. X is equal to 0, write direct this value because this is the minimum value, starting value. So with the help of using the binomial probability distribution table, you can find the probability of the different values of the p with different values of n. The maximum value of the n in the binomial probability distribution is the 20. If value is more than 20, then we use another probability distribution. We convert the binomial distribution, or we transform the binomial distribution according to the requirement into Poisson or normal probability distribution. So in exam you have to use the different probability distribution table. Result will be same, but solve this question only using both method. Number first by using the formulas, and number second table both. And after this in other question we will use the binomial probability distribution table. So next question for homework, solve the question number 4, question number 6, question number 7 and question number 9, page number 165 of your book, Introduction to Statistics by Walpole, 3rd edition. Solve this question using the table, not by using the formula. Okay, Allah Hafiz. Next time we will start Poisson probability distribution.